In this lesson, I am going to teach you how to determine the electron configuration for atoms on the periodic table. We're going to keep it pretty basic. Everything we are working with today will be a neutral atom. That means it's not an anion, not a cation, no charge, just the elements as you would see them on the periodic table. And I always, when I'm teaching this in class, I usually start off by writing this series of numbers and letters on the board, and I usually just ask my students to take a look at it and think about it. And I try to get them to figure out, can you determine what kind of pattern I've got going on here? Think about the things you know in chemistry. Think about the most useful thing you have in chemistry at this point, and maybe how it relates to these letters and numbers. So what I'm hoping you're thinking about is the periodic table and how this pattern relates to how we read the periodic table. So before we get into the lesson too much, I'm just going to put the periodic table right here, and I'm going to point a few things out. We know that as we move from left to right, these are the rows or periods of the periodic table. We have row 1, not much on row 1, just hydrogen and helium. We have row 2, row 3, row 4, and so on and so forth. So when you're looking at this pattern, these large numbers in front, the coefficients, the 1, 2, 2, 3, these represent the rows of the periodic table. The letters represent the blocks, and just in case you need a little refresher on the blocks of the periodic table, I'm going to mark those for you right now, and I'll just use this one. The first two columns of the periodic table, this area right here, this is the S block. And you'll notice I included this blank area because helium actually comes over here for a visit. It's kind of like the cousin that comes at Christmas and won't go home. So helium is actually a part of the S block. And then over here on the right-hand side, this area, this is the P block of the periodic table. And then we have the area in the middle, our transition metals. This is the D block of the periodic table. And then the bottom section, which honestly in beginning chemistry, most of you will not spend much time down here, but this is the F block of the periodic table. So it's almost like you take a continent and you break it up into countries. We have taken the periodic table and we have divided it up into 4 main regions. And we're going to talk more about those in a minute, and I've got a little chart that gives you some additional information. So going back to this pattern, you can now understand what these letters stand for. This is your S block. Anytime you see P, we're looking in this area. If you see D, we're looking right here. And I don't have F up here. You'll notice I've got some dots. That just means it keeps going. I'm not showing you the whole thing yet. So you might want to go ahead and just do a real simple drawing of a periodic table somewhere in your notes, just making sure you understand where S, D, and P are. We'll go ahead and mention F, even though we're not going to spend much time there. And also, again, note that helium is over for a visit. So, what is electron configuration? I tell my students, think about it as the address and directions to a specific element on the periodic table. And when we do electron configuration, a few things you're going to notice is we read the periodic table like a book, meaning we always start at the very top, we read across. When we get to the end of a line, we drop down one and we go back to the left, left to right, drop down one, left to right. Again, just like you would read the sentences in a paragraph. Not only do we pinpoint the address of the element, we're going to show you how to get there. And those directions are really important because they start to give us a much broader picture of what the atom looks like. You get a lot of good information from electron configuration. So before we jump in and do examples, I'm just going to point a few things out that we're going to be thinking about. First of all, electron configuration technically is the arrangement of electrons in specific orbitals for a specific element. Basically, it tells us how many electrons are on each level, and it also gives us even more information about the types of orbitals that they are traveling in. So again, it's a lot like the address of and the directions to an element. Some quick points I want you to keep in mind while we're doing examples. We will always read the periodic table like a book from left to right, and then you drop down to the next row, left to right, so on and so forth. We will always start at home. Home happens to be hydrogen, and that's a good thing because home starts with H, so it's easy to remember, but we always will start here. Every electron configuration we do starts with hydrogen. There are 4 subshells or sublevels represented on the periodic table. We just talked about those, S, P, D, and F. Also, when we're thinking about the different periods of the periodic table, this little part right here, I'm going to show you what that means. Period 1, that means row 1 has an S sublevel. Period 2, row 2 has S, but if you keep going, it's also got a P sublevel represented. The third row has S, P, and you're going to learn it also has D, because a little secret about this D block, they are actually 1 level behind. So what looks like row 4 is actually row 3 for the D block. If it looks like row 5, it's actually row 4. So you may want to make a note here that the D block is always 1 level behind. The F block is actually 2 levels behind, and we'll talk about that in a little bit. So that's what this means. Row 1 has only the S subshell. Row 2 has S and P. Row 3 has S, P, and D, and again, so on and so forth. And here's your reminder. The D block is always 1 level behind. The F block is always 2 levels behind. And here's how you can really simplify this when you are thinking about electron configuration. Think row, block, and then you count over. So before I jump into some examples, I'm going to show you what I mean by that. And I'm just going to read it again like I'm reading a book. So if I were to start at hydrogen, I would say 1s2. There's nothing else on row 1, so I'm going to drop down to 2. Row 2, S2. That's 2 blocks wide. You can think of it that way. Now keep going because we're not done on row 2. Now we're at 2p6 because the P block is 6 elements wide. Now we're at the end of that row. 3s2. 3p6. Row 4, block S2. Now remember the D block's a level behind, so this is 3D10. Back to 4P6. 5S2, a level behind, 4D10. Back to 5P6. And so you see how we're reading it. So it's row, block, count over. And what you've probably seen is the exponent in the S block can go to a maximum of 2. The exponent for P is going to be a maximum of 6. D is going to be 10, and F is actually 14. So again, we'll talk about that in a little bit. So that's what I mean by row, block, and count over. Now, just a little bit more information before we start these. So it's good to know that S, P, D, and F are called sublevels, or some people may call those subshells. The S sublevel has 1 orbital, which can hold a maximum of 2 electrons. The P sublevel has 3 orbitals, which can hold a maximum of 6 electrons. The D sublevel has 5 orbitals, which can hold a maximum of 10 electrons. And the F sublevel has 7 orbitals, which can hold a maximum of 14 electrons. Now, if you haven't had a lesson on quantum numbers yet, that might be just a tad confusing. Think of orbitals as parking spots, and 2 electrons can park in a spot. Electrons are kind of like motorcycles. You know, it's not unusual to see motorcycles traveling in pairs, and sometimes when they're parked in a spot, 2 motorcycles can fit in a regular parking spot for a car or truck. Electrons are the same way. So it makes sense you only need 1 parking spot in S, since you're only going to have a max of 2 electrons. You only need 3 parking spots in P because you're going to have a max of 6. And if you can put 2 electrons in a spot, 3 spots are plenty. When we do orbital notation later, you'll see it's notated by that's 2 electrons. That's 3 spots. So there's your 3 orbitals with 1, 2, 3, 4, 5, 6 electrons. P looks like this: 1, 2, 3, 4, 5 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. You'll notice I'm using Hund's rule as I fill these electrons into these orbitals. You put 1 electron in each before you go back and double up. And again, you can catch that on a quantum number video later. And then we have 7, 3, 4, 5, 6, 7 with a total of 14 electrons in F. And honestly, when I'm teaching this to my students in high school, we don't even talk about the F sublevel, but just in case there's some college students watching this, I'll mention it kind of on and off. Now, the basic pattern for electron configuration looks like this. This is very similar to what I just wrote out for you earlier. Read it like a book. Start with level 1, the S block. There's nothing else on level 1, so you head down to level 2. You go through the S block, and then you keep moving right, and you hit P, and then you hit level 3, and so on and so forth. Now, we can get a little more detailed, and we can actually include the number of electrons in this. And number of electrons, we're talking about these numbers right here. And again, you see that S has a maximum of 2, P has a maximum of 6, D will have a maximum of 10, and I've even got F represented here. It's got a maximum of 14. So when you hear the phrase electron configuration, you're going to be looking at something very similar to this. We find our destination, we start home, we go through all the directions to get to that destination, and we're done. So that said, honestly, it is just really easier for me to jump into some examples now that you've had a little background information and show you how this is done. So we are going to start today with some things in the S block. Make sure you've got your periodic table handy in case you need it. And let's start with magnesium. So our first example will be magnesium. Let's find one that works here. I've gone through a record number of Sharpies during this pandemic, so starting to wear them out. All right, magnesium. Now the first thing we want to do is locate magnesium on the periodic table. So when you look at the periodic table, magnesium is right here. So magnesium is row 1, 2, 3. So it's the third row. It's in the S block, and it's the second one in the S block, because when you're looking at the S block, 1, 2. So magnesium's address is 3s2. So if someone asks you, where does magnesium live on the periodic table, the address that you would give them, and I'm just going to jot this down up here, would be 3s2. That's where we're going. But when we do electron configuration, we have to tell somebody step by step how to get there. So let's look at magnesium. We're going to start home. So 1s 2. Remember helium's in the S block. There's nothing else on row 1. So we're going to write down 1s2. So now we drop down to the next row. 2s2. Are we there yet? Nope. If we stop at 2s2, we're at beryllium's house. So let's keep going because there's some more on row 2. Now we are still on row 2, but we've hit the P block. So this is 2p6. And I've got that 6 because it's 1, 2, 3, 4, 5, 6 wide. Now, so the question might be, are we there yet? And the answer is no, because now we are at neon's house. There's nothing else on row 2, so drop down to row 3. Now we are in 3s, but it's kind of like we're on Magnesium Street now. So how many over do we go? 1, 2. So 3s2. So magnesium's electron configuration is 1s2, 2s2, 2p6, 3s2. And we've landed right on magnesium. Now let me tell you what's really cool about this. Once you've written this electron configuration, you now have a real good idea of what that atom looks like in terms of what levels the electrons are on. So for example, and I'm just going to do like a little cross section of the atom. So here's magnesium's nucleus. Now magnesium is number 12 on the periodic table. So we know it's got 12 protons and 24 minus 12, 12 neutrons. So I'm just going to make a little note there, 12 protons, 12 neutrons in the nucleus. Now, as I go through here and look at the row numbers, the highest row represented is a 3. That means magnesium has 3 levels of electrons. There are 2 electrons on level 1, so I'm just going to put a 2 there. There are 2 plus 6 more. You've got to add these together because there's a total of 8 electrons on level 2. And there are 2 electrons on level 3. And if you add 8 plus 2 plus 2 together, that gives you 12, which should match for a neutral atom the number of protons because you have the same number of protons and electrons in a neutral atom. Something else I want to point out here that's very important, magnesium has 2 valence electrons. Valence electrons are the outermost electrons that are responsible for bonding. They also help determine the physical and chemical properties of the element. So we have 2 valence electrons. And again, valence electrons are the outermost electrons, so it's really important to know where those are in an atom. All right, let's take a look at another one. Let's do potassium. So we're going to do another one in the S block. Now, let's see where we're going. So it's kind of like we're putting potassium into our GPS, and I see potassium here. Potassium is row 1, 2, 3, 4. It's the S block, and it's the first one. So if you're counting over, it's 1. So it's going to be 4S1. That's the address that we're going to. So I'm just going to jot that down. But I've got to start at home. Just like when I go to work every morning, it would be so wonderful if I could just snap my fingers and be at work. But I know that I have to leave my house first. I have to go to the end of the road. I have to take a left. I have to go to the end of the next road. I have to take a right. I have to go past certain places, certain little checkpoints to get to work. That's what we're doing when we write out this electron configuration. We're giving all the details on how to get to potassium. So I'm going to talk through it first and then we'll write it down. So again, we're going to potassium. So we're going to start off with 1s2. There is nothing else on row 1. So now we're going to drop down to 2s12. Keep going. Now we are at 2p6. 3s2, keep going, 3p6. Are we there yet? No. If we stop at 3p6, that puts us at argon's house. So keep going, 4s1. Now notice I did not say 4s2. 4s2 would have put me at calcium. I'm stopping at the first house on this street, not the second one. So it's going to end with 4s1. So now let's write that down. So it was 1s2, 2s2, 2p6. Now we're ready to move to row 3. 3s2, we're not there yet, keep going. 3p6, 4s1. So the very last one is kind of like the final address. So let's take a look at what the calcium atom looks like. Potassium. So let's draw the nucleus. Now, potassium is number 19. So potassium has 19 protons. Now, potassium also has a mass of about 39, round it to a whole number. 39 minus 19 is 20 neutrons. Now, as we peruse through these coefficients, we're looking for the highest row represented, which in this case is row 4. So we have 1, 2, 3, 4 levels of electrons. We have a grand total of 2 electrons on level 1. We have 6 plus 2, which is a total of 8 electrons on level 2. We have a total of 2 plus 6, 8 electrons on level 3, and we have 1 electron on the 4th level, so potassium has 1 valence electron. So now you can see this is really starting to give us a picture of what the atom looks like. So there's a lot of great information that we get from electron configuration. So let's look at something in the P block. Let's do aluminum. Now, aluminum's final address is going to be, let's see, 1, 2, 3. So aluminum is on row 3. It's in the P block, and it's the first one. So it's going to be 3p1. So jot that down so we know where we're going. All right, so start at hydrogen. I'm going to walk you through it first, then we'll write it down so you can see as I move through the periodic table. 1s2, 2s2, 2p6, 3s2, 3p1. Now we did not go all the way to 3p6 because that would have put us at argon. That's like you needing to stop at the first house on the street, but you pass it and you go on down like 4 or 5 more houses. We had to stop right here, so that put us at 3p1. So that was a really easy electron configuration, so let's write that down. We have 1s2, 2s2, 2p6, 3s2, 3p1. Now, let's take a look at what the atom would look like for aluminum. So aluminum has an atomic number of 13, so there are 13 protons, and 27 minus 13, because you're going to round that to a whole number. So 27 minus 13 is going to be 14 neutrons. We have 3 levels of electrons because 3 is the highest row number represented. So 1, 2, 3. There are 2 electrons on level 1, 2 plus 6, 8 total electrons on level 2, and 3 plus 1, 3 electrons on level 3. So aluminum has 3 valence electrons. So hopefully, now that you've seen a few examples, you can see what we're simply doing is we're breaking the directions up into chunks. You're doing it by row block, row block, row block, always going to the maximum number of electrons. That's 2 for S, 6 for P, 10 if we're dealing with D, except for that very last one, because the very last one could fall anywhere within a block. For example, if we would have been going to phosphorus, we would have ended with 3P, 1, 2, 3. If we would have been going to chlorine, we would have ended with 3P, 5. So that very last one is the one where you've really got to be careful because that's where you're pinpointing that final address. Let's do another one real quick in the P block. Let's do bromine right here. Bromine is level 4, P block, and it's the 5th one over. So 4P5 is going to be the final address. So let's take a look at our periodic table and go to bromine. So we're going to start at home. So you're going to start with 1s2. Nothing else left on row 1. So now you go down to 2s2. Keep going. 2p6. 3s2. Keep going. There's a little more over here. 3p6. Not there yet. 4s2. Now we're running into this D block. And what I need you to remember about the D block is the D block is always 1 level behind. So this looks like 4, but it's actually 3. So now you're hitting 3D10. Go all the way through it because we're not there yet. Now you're back to 4, 4P, 1, 2, 3, 4, 5. So I'm going to read that again. It was 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. So let's write that down together. One S2, 2s2, 2p6, 3s2, 3p6, 4s2, now we're going to drop back to 3d10 and then to 4p5, and that puts us at bromine. So really, the strangest thing you have to remember today is that that D block is 1 level behind. So let's do one more in the P block. I'm not going to draw this atom. We've seen several of those. That was just a little extra that I wanted to add on. We'll see some more of that later. But let's go ahead and pick out another one in the P block. No, actually, we've done 2 P blocks. Let's pick out something in the D block. Let's take a look at copper. So copper is located in the D block right here. That looks like row 4, but I know it's actually row 3, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9th one over. So it's 3D9. And we're just doing the parent element of copper, meaning I'm not giving you copper plus 2 plus 1, anything like that. We would just call this the parent element. So to get to copper, we're going to go through 1s2, 2s2, 2p6. Are we there yet? No, that would put us at Neon's house. Keep going. 3s2, 3p6. Not there yet. 4s2. Now, here's Copper Street, okay?